Students, we'll see the fourth module here. Okay, we'll be just revising it with the topics, whatever we have seen in the previous classes. So, first we'll start with the dynamic programming, where in dynamic programming, you are going to see the introduction, how to compute a binomial coefficient we have seen, Warshall and Floyd's algorithm, and the knapsack problem. Just we will revisit it. Okay, you know that it is a planning concept where it will be solving all the smaller subproblems. Smaller subproblems will be solved and it will be stored in the table. So we have seen what is the formula for binomial coefficient. The binomial coefficient we have seen the formula is nothing but you have seen that C of n comma k is C of n minus 1 comma k minus 1 plus C of n minus 1 comma k. And we have also seen what the initial condition n comma 0 and n comma n it is equal to 1. So we will be using this table, solve the value. Anyway, we have no C of n comma k is depending upon C of n minus 1 comma k minus 1 plus C of n minus 1 comma k. So row wise you solve everything and come. When you go for this, if you take the third row, we will be going only up to 3, not up to k. Always your n should be greater than or equal to k. Okay, you can solve it for 6 comma 4, but you cannot solve it for 4 comma 6. That's the main thing. So here we are writing the algorithm based on the formula, and you will be returning with the value. So it's a recursive formula, so you need to have an initial value. So for the initial value only we have this values, that is for any recurrence equation we need the initial values. If you see the so from this the time taken is again it is based on a triangle as well as rectangle. So based on that we are going to find out the two parts. By using that summation formula we will be finding out. The Warshall algorithm is adjacency matrix will be given, you will be finding out the transitive closure. So it will be a Boolean matrix. So any matrix will be depending upon the previous one. So in such a case you will be using a vertex as the intermediate vertex will be there. From I to j there will be a vertex k. So for that you have a formula. It's a Boolean formula. So we use the Boolean operation or and then it will be depending upon the previous matrix. So Rij of k is Rij of k minus 1 or Ik of k minus 1 and Rkj of k minus 1. So based on this, we will be finding the value. So here you can see that if phi j is 0 in the previous matrix, in the new matrix, if you see ij becomes 1. How? If your ik is equal to 1 and your kj equal to 1, then your ij will be equal to 1. So based on this, we are writing a iterative algorithm. Since it is having 3 loops, the time taken will be of n cube. So this is all about your Warshall algorithm. Now if you see the Floyd's algorithm, it is for calculating the distance matrix. So here also we go according to the same procedure of here Warshall, but only thing is there it was Boolean, here it is value. What is the value? Value is you have to find out the minimum among the two distances. If you are having two edges which is having two values, then you will be finding what is the minimum value. So minimum of Dij of k minus 1 comma, that is it can be either direct one or indirect one. Indirect is going through a intermediate vertex k. So by going through the intermediate vertex, if you get a minimum value, then that will be, so your Dij of 0 is nothing but the weighted matrix. So here you are given a directed graph, you take the weighted matrix as it is for D0, then making each one as intermediate, you will be trying to get the solution. So here also the three loops are there, the formula. So the time taken is n cube. So next we will move on to knapsack problem. Knapsack, you will be given with n items. You have to find out the maximum profit for all the, so you are using a maximum formula and you know the initial value for the recurrence. There it was D0 and W0 was the initial value, but here you have to find out like binomial coefficient. We are saying that we have 0 comma I, j and I comma 0, both are 0. Your goal is to find V of n comma w. So you are finding with using the formula. So here it is given with 4 items with its corresponding weight and value. Maximum knapsack capacity is also given. You just find out by filling the values in the table. So this memory function is nothing but your drawbacks of top down and bottom up is overcome by mixing it as memory functions, where you will be filling it with the virtual initialization with the null value. So if at all you want to find out a particular entry, only those entries will be calculated here. So initially all will be 0. The first row, first column is 0, remaining all it will be null. So if you check the value as null, you calculate it. If there exists already a value, don't calculate it again, you just retrieve it from the table. So here you are given with the algorithm. For this we have seen a program also how to do the memory functions. So this is all about your dynamic programming. Next we will see in the fourth module you have 2 chapters. The next one is your greedy technique. In greedy technique, what you will be doing, in greedy technique what you are going to take is you will be in the greedy technique what you have is you will be having the Prince algorithm, Kruskal algorithm, Dijkstra's algorithm, and the Huffman trace. Greedy means you know that you will be greedy enough to for anything. So here it is considered as the optimization problem. Prim's algorithm and Kruskal algorithm, it is almost the same. In Prim's algorithm, what you do is you know what is a spanning tree. Spanning tree is connected acyclic graph with a minimum value. Minimum cost spanning tree is minimum value. So you need to construct it as each time when you will be going it, we will be taking the least adjacent value, and based on that, if it is not adjacent, then we will be giving it as infinity. So based on among this, you will be finding out. Now, similarly, through a intermediate, if you are getting a list value also, or for example, A to B is 3 and A to F is 5. Now, since you have visited B, now you can say it as instead of A to F, you can go for B to F also. So whatever is there in the tree vertices adjacent to it, you are finding the values and you are getting the minimum cost. But whereas in the Kruskal algorithm, what we do is in the Kruskal algorithm, we sort the edges according to the edge cost, and it need not be always a tree structure. You will be having a group of trees. All these trees will be joined together to form a tree structure at the later stage. So this is how you go for the Kruskal algorithm. Both you have to see to that it doesn't form any cycle. Here, whenever you take a least cost value also, if it forms a cycle, you just discard it. So based on that, we will be finding out the minimum spanning tree. So here we use the union and find algorithms, and you have two things. One is based on the linked list, you will be having union by size. Based on the tree structure, we will be using the union by rank algorithms will be used. This can also be used for the games of for path compression, etc. Dijkstra's algorithm is nothing but we will be just taking a source vertex, and from the source you consider all the remaining vertices as the destinations, and we will be moving ahead with the values. So that is nothing but your Dijkstra's algorithm. Finally, we have the Huffman tree, where you will be given with every characters. Each character will be having its own frequency. So from the frequency, by using the algorithm, you are constructing the tree structure, labeling it, and getting to know what is the code word. So this is all about your fourth module, where you have 2 chapters. One is your dynamic programming and another one is your uh, greedy technique. So based on this, any algorithm given, any problem given for all these types of problems, you are supposed to do it. So you can just refer some previous question paper I've shared with you in the class with some examples, so that assignments you can do it. So different graph problem you take, and you will be you're supposed to solve it and find out what is the time taken. So thank you guys. This is all for the fourth module, where you have greedy technique and the dynamic programming technique.